Hello pre-calc honor students, here we are with vectors and planes. And we're going to try and sketch planes and to find equations of planes in 3 space. But first let's review what happens in 2 dimensions with something like 2x plus 3y equals 12. Well, the main idea is to look for the x and y intercepts. And so you'd set up your little chart and set x equal to 0, and when you do that you cover up the x, you get 3y equals 12, so y equals 4. And then you could set y equal to 0, cancel out the y there, 2x equals 12, so x equals 6. So we can quickly come up with a nice line through 6, 0, and through 0, 4, and let's get a line through those. There you go. Pretty easy way to come up with the equation for a line. Now we can do that in a plane too. Now we're in 3D. To find out where the x-intercept is, remember the equation of the x-axis has equation. Do you remember that? The x-axis has equation y equals 0 and z equals 0, because it's the intersection of these 2 planes, the xz plane and the xy plane. So think of that when you make your chart now. We've got 3 variables, x, y, and z, and so you set both y and z equal to 0. When you do that, you get 2x equals 12 then, so x equals 6. And now if we set x and y equal to 0, we end up with 4z equals 12, so z equals 3. And then if we set x and z equal to 0, we end up with 3y equals 12, so y equals 4. So there's 3 points we can plot. 6, 0, 0, 6 way over here, 0, 0, 3, and 0, 4, 0. And let's connect them with some lines. Oopsie, that went way off the table. Don't quite understand that. There you go. There's one, there's another one, and there's another one. Okay. Let's get this one gotten rid of here. Cut. Okay. Now, that's only showing what's going on in the first octant, and we can shade it in with some of our, let's get some of our yellow paint out there. There we go. And that's just a picture of a triangle that's in that plane. It's not the whole plane. The plane extends and cuts through many different octants. I think it's probably going to miss entirely the octant on the opposite side of the first octant, but that's our sketch for planes. Very similar to sketching a line in 2 space, but you find the x, y, z intercepts. Now you might say, well, Mr. Lang, what happens if it doesn't have an intercept? That's entirely possible. Let's look at some other equations. What about z equals 2? Well, z equals 2 will actually end up being a parallelogram. And I happen to have a little handy parallelogram graph in here somewhere. There it is. Z equals 2. So I look at 0, 0, 2 on the z-axis, and I set my parallelogram like this, and I try and make it look like it's parallel to the xy plane. And now I can move this thing around. There. Put it anywhere in here. That's basically will keep on extending out, won't it? Through z equals 2. Now the thing is, I want to make sure it's going through z equals 2 though. 0, 0, 2. So you can put that anywhere like that. I'll put it there. Let's shade that in. There's your z equals 2 plane. Parallel to the xy plane. And going through this point here of 0, 0, 2, that's just one of them. Here's a point way over here of 1, 2, 3, 4, 5, 6, 7. 0, 7, 2. And we can have motion in the x direction too. This is 1.2, comma 0, comma 2. Notice what they all have in common is z equals 2. That's parallel to the xy plane. Let's try another one now. Y equals 3. Well, we got the point y equals 3 right here. That's 0, 3, 0. But it's going to be parallel to the xy plane. So when we set up our parallelogram now, do it this way. Oh, it doesn't want to bend the other way. Oh, we've got a little trick I can do. I can flip it. If you don't like that, you can always take an object. And flip. Up, down. Oh, that was not the right flip. Flip. Left, right. Flip again. Left, right. Yeah, that's not going to do it. Let's just draw it. It's alright. Cut. What you can do is go like this. Start going parallel to the x-axis, and then go parallel to the z-axis as well. There's an example of doing it by hand. And so we get something parallel to the xz plane. And you can shade that in. There's the line y equals 3. Finally, y equals x. What we can do is just look at y equals x in this plane. So that's this line like this. Right, going through these points. All these points have the same x and y coordinate. And we can project this upward along the z here. And we can make another thing like this and make a parallelogram. There's our parallelogram. Now that's just one parallelogram in the whole plane. And notice it's not parallel to any of the coordinate planes, but it does pass through the z-axis. And there's our plane. Okay, now how do we create the equation of a plane? Go in the other direction. Instead of slope, we need to find a vector perpendicular to the plane. So let's go back to 2D to see how this works. Remember when you're in 2D and you want to graph this line 2x plus 3y equals 12, what does the vector 2, 3 have to do with it? Well, 2x plus 3y equals 12, we said went through 6, 0. Oopsie, let's get our marker out again. 6, 0, and 0, comma 4. And let's get our equation of a line in there. There's the line. Well, now let's look at the vector 2, 3. Start here at 0, 0 and go over 2 and up 3. Do you see how that's perpendicular? So 2, 3 isn't anything parallel to it. These coefficients on x and y end up giving us something that's perpendicular to the plane that we're looking for. That's going to be essential now in our setting up the equation of a plane. Now recall from geometry that if a line M is perpendicular to a plane, then that same line is perpendicular to every line of a plane that passes through the foot of M. So let's get some other lines in here. There's a line through the foot. Here's another line through the foot. And M is going to be perpendicular to all those. Perpendicular to that one. Perpendicular to this one. Now let's see how this applies in vectors. We can look at the vector AN, perpendicular plane containing A, B, and C. So it's perpendicular to everything in here. It's perpendicular to this vector, this AB vector, right? So let's write that down. AN is perpendicular to AB. AN is also perpendicular to AC. another point in the plane, right? And now if we think of any point, any general point, P, call it x, y, z in the plane, AN will be perpendicular to that as well. It's perpendicular to all those. Perpendicular this way, and that way. So, if P is any point in the plane, then a vector equation of the plane could be vector AN dot vector AP equals 0. So that would be a vector equation. Now we're going to turn this into a Cartesian equation in x, y, and z. So A is a fixed point in the plane, x naught, y naught, z naught. Let P be any point in the plane, x, y, z. And let AN be a vector perpendicular to the plane with coordinates A, B, and C, ABC. And we're going to call this the normal vector to the plane. So now we can take the vector equation and turn it into a Cartesian equation. We just said vector AN was going to be ABC. And for vector AP, we have to go from A to P. So we actually have to go P minus A. So vector AP equals P minus A, and P was XYZ, and A was X naught, Y naught, Z naught. So we get X minus X naught, Y minus Y naught, Z minus Z naught, and that's all equal to 0. Now we do the dot product. A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught equals 0. So it's AX minus AX naught plus BY minus BY naught plus CZ minus CZ naught equals 0. Or AX plus BY plus CZ equals AX naught plus BY naught plus CZ naught. And replace all this with the constant. So there's our variables x, y, and z, the point in the plane. There's that normal vector ABC. So it works out in 3D as well, that the coefficients on the variables end up being a vector perpendicular to the thing you're trying to describe, in this case a plane. So here's our theory. If ABC is a non-zero vector perpendicular to a plane with point x naught, y naught, z naught, then an equation of the plane is ax plus by plus z equals d, where d equals a times x naught plus b times y naught plus c times z naught. So in our first example, vector 3, 4, negative 2 is perpendicular to a plane that contains A, which is 0, 1, 2. Find an equation of the plane. Well, AX plus BY plus CZ will equal D. Our A, B, and C is right here, the direction, the vector perpendicular to the plane. So 3x plus 4y minus 2z equals D. How do we figure out D? We plug in the point 0, 1, 2. What's the distinction here? These are not both points. Vector V, this vector 3, 4, negative 2 is perpendicular to the plane. It's our normal vector to the plane. 0, 1, 2 is a point in the plane. So now we're going to use that point, put 0 in for x, 1 in for y, and 2 in for z, and you get 4 minus 4, so you get 0 equal to D. So we get 3x plus 4y minus 2z equals 0. This is a hard one to actually sketch, though, because its x, y, and z intercepts are all 0 because it goes to the origin 0, 0, 0. Now, example 2, if a equals 1, 0, 2 and b equals 3, negative 4, 6, find a Cartesian equation of the plane perpendicular to AB at its midpoint. Well, I think we're going to want this midpoint, but we can also use vector AB will be the normal vector to the plane. Okay, so let's figure out vector AB, which is going to be b minus a. So that's 3 minus 1, comma, negative 4 minus 0, comma, 6 minus 2. So we get 2, negative 4, 4. That's vector b minus a, which ends up being our normal vector. 2, negative 4, 4. Now we need a point. Well, the midpoint. It said must go through the midpoint of AB. So that's going to be, let's call that M. and that's going to be 1 plus 3 over 2. I'm averaging all the coordinates. 0 plus negative 4 over 2, and 2 plus 6 over 2. So we get 2, negative 2, 4. 2, negative 2, 4. So this is great. We've got the coefficients, and we've got a point. So the coefficients come together to form 2x minus 4y plus 4z equals some constant d. And now we can put our point in. 2 times 2 minus 4 times negative 2 plus 4 times 4 equals d. So it's 4 plus 8 plus 16 equals d. So we get 30. D equals 30. So we may have messed up here a little bit somewhere. Let's find out where. A very minor mistake. This is 12 and 16 is 28. 28 equals D. So we've got our equation now. 2x minus 4y plus 4z equals 28. And you must get rid of any common factors. So when we divide by 2, we get x minus 2y plus 2z equals 14. And that checks out. Okay, now I just want to show you this alternate approach because it's a different way of thinking about this problem. And that is to realize that, okay, we start with A and B, and we drew a line between them and came up with a midpoint M. And we went through vector A, B, and so forth. But we can also use a little trick from geometry. That is, any point in the plane, it's called P, with coordinates x, y, z, must be equidistant from the endpoints of this segment, right? That's how you create a perpendicular bisector of a line segment, and now we can create the perpendicular bisecting plane of this line segment in 3 space. Oh, quite a thought. Let's just check this out then. So PA, distance PA, must equal distance PB. So x minus 1 squared plus y minus 0 squared plus z minus 2 squared, square root all that, must equal the square root of x minus 3 squared plus y minus a minus 4 squared plus z minus 6 squared. So square both sides and start expanding. So you get x squared minus 2x plus 1 plus y squared plus z squared minus 4z plus 4 equals, on the other side, x squared minus 6x plus 9 plus y squared, this is y minus minus, that's plus 8y plus 16 plus z squared minus 12z plus 36. And note what cancels here. I mean, it looks like it's hard at the beginning, but it's kind of just a one-step thing. It's just a matter of simplifying all this now. Our x squareds cancel, y squared from both sides, and z squared from both sides. And, let's see, we've got a negative 6x here. So let's add that to both sides to get 4x. We've got an 8y over here, and no y's left over there, so let's call it minus 8y. A minus 4z here and a minus 12z, so it's going to call it plus 8z equals, and now this whole side on the right is 9 and 16 and 36. That's 25 and 36 is 51. Minus the stuff we have from over here, which is 1 and 4, so minus 5. So 4x minus 8y plus 8z equals 46. And I think we can divide through by, should have been able to divide through by 4. Let's see. I think it's 56. I think it was off by 1. Yeah, this is 61. Yeah, this is 61 and this is 56. And now when we divide by 4, we get x minus 2y plus 2z equals 14. Same equation again. All right, flange out.